So good morning all. We are going to start the lecture number 62 of data structures and algorithm. Am I audible to all?
Yes, sir.
Okay.
Yes, sir.
So in last lecture we have completed our unit number 4, that was tree. In tree we have learned, I am just recapping the topics that we have covered in the tree. We have learned about the basic terminology of the tree, and then we have started learning various types of the trees, and various types of the trees, which includes binary search tree. First of all, we have seen how we can create a binary search tree, how we can insert and delete into the binary search tree, how we can perform traversing of a binary tree. Three types of traversing, that are in order, pre-order, and post-order, we have learned. And then we have move on to the AVL tree. AVL tree insertion we have seen, and deletion we have seen. Various kind of rotations that we can perform on the AVL tree we have seen. And then we move on to the B tree, in which again we have seen insertion and deletion. And in this way we have completed the fourth unit, that is tree. So any doubt you have in that? In last lecture we have completed B tree. Okay, so I am going to start the next unit, that is unit number 5, graph. Now uh, so tree was a linear data structure or non-linear data structure?
Non-linear.
Non-linear.
No,
Why it was a non-linear data structure?
Non-linear, sir,
Why it was a non-linear data structure?
because the elements are not सर एलिमेंट्स जो होते हैं वो सिस्टमेटिक या फिर सीक्वेंशियल वे से एक दूसरे जोड़े एक दूसरे सीक्वेंशियल वे से नहीं लगे होते हैं इंडेक्सेस के थ्रू.
Anyone else who can give us the answer of this?
Sir, elements are not arranged in a linear fashion.
Okay, anyone else? Why the tree was non-linear?
So because of the memory allocation of the nodes is not in the linear manner.
Linear manner. What do you mean by a linear manner?
One by one. Continuous.
So one by one.
One by one after another. One after
Yes.
another actually. That
Yes.
was actually one after another. So non-linear data structure means कि all
तो
the
सर ये
elements.
सीक्वेंशियल वे तो हुआ.
तो मैंने मना कहाँ किया बेटा?
ओह सॉरी सर मुझे लगता है मैं गलत बोल गया.
बेटा आप गलत बोलोगे तो मैं बताऊंगा आपको.
ओके सर.
है ना? So sequential is not proper answer actually. It is okay, but it is not a proper answer. Linear word should be there. So linear manner में arranged होना. Linear data structure means linear manner में arranged, one after another. Sequential तो every data structure is actually sequential. Stack is sequential. Sequential means हम array के through represent कर रहे हैं.
ओह यस सर यू आर राइट.
So
इस जगह पर लीनियर सब सही रहेगा.
So linear means कि one after another we are arranging the data elements of the data structures. Now in non-linear data structure it is not possible actually. So we have seen that tree, that is a kind of non-linear data structure in which we are not arranging the elements in the linear manner. It means one after another. Okay, so it will be in the hierarchical form. So the another data structure we are going to learn, that was again a non-linear data structure, which is graph. So which is a kind of a tree actually, we can say extended part of a tree that we are going to learn now. So that is actually known as a graph. You might have studied graph in your mathematics also, I think. Please let me know yes or no.
yes, sir.
Graph is a very important topic of mathematics also. Graph theory is like itself is a we can say a paper itself is a paper or a subject in the mathematics. Okay, so graph. So can anybody tell me what could be a graph? Before I show the definition, what could be a graph?
Graphical representation of data.
That is okay, but what is a graph? I am asking about the definition of graph now.
Increasing.
Graph. The graph is something when we try to
Okay.
actually represent the data in a Cartesian plane, x or y or z axis.
Okay, so you all are thinking about that graph which you have like drawn using x and y axis. But I am actually talking about the graph which is
सर
which is something else in
परिक्षेप
that.
परिक्षेप पर डाटा तथा डाटा को रिप्रेजेंट करने का माध्यम है सर ग्राफ, जो कि 3D भी हो सकता है, 2D भी हो सकता है.
So let us see what is a graph actually. So
Sir-
we are not actually talking about.
Sir, graph.
Yes, yes.
Sir, graph is a representation of set of objects.
Very good. क्या नाम है बेटा आपका? What is your name?
Chanchal.
Chanchal. Okay, very good. So let us see now the definition of a graph. Which like it is okay, which is a kind of a representation of some objects. Okay. So what do you mean by an object here? Good, you have tried. Good. What do you mean by object? What do you want to say with object now?
सर ऑब्जेक्ट तो वो जो इक्वेशन दे रखी होती हैं वो होते हैं ना ऑब्जेक्ट.
No. Tell me, anyone else? Chanchal, you tell me just what do you mean by an object? Just guess it.
Sir, collection of vertices of edge.
Okay. Chalo, let us look at the definition of the graph now. Okay. So before starting with the graphs, okay, can anybody tell me what could be the applications of a graph? Where you can see graphs in your real life.
ट्रांसपोर्टेशन प्रॉब्लम में सर जो कॉस्ट है ट्रांसपोर्टेशन की उसको ग्राफिकल वे से रिप्रेजेंट करने के लिए कि इंक्रीज हो रही है या डिक्रीज हो रही है.
Okay, or other applications?
So to represent population density. Census.
Okay, or
सर ग्राफ कई तरह के होते हैं ना, जैसे पाई ग्राफ होता है, कई तरह के होते हैं सर ग्राफ. तो नहीं, वो तो चार्ट होता है.
applications I am talking about. Daily life में where you think that you uses graphs.
सर जो
As-
मैनेजमेंट की कॉस्ट है वो जो
Map, very good. Map.
सर एक और बताओ.
That हाँ बताओ.
सर जैसे हम कोई वस्तु का निर्माण करना चाहते हैं तो हमें वो वस्तु
Please be in English, beta. I request you
Oh.
to be in English.
हाँ
okay?
yes sir.
Otherwise, you need not to speak.
Yes sir. Graph is used to construct cost and construct idea and construct number of things to calculate through graph. It is increase and decrease or where we can made this type of thing.
Okay, I am actually not getting you what you are saying. So
Sir, मैं
let
ये
me-
कह रहा हूँ कि-
let- नहीं, no need to speak in English, Hindi. Okay, please
Okay,
be
sir.
try to English, beta. This is 61 lecture, and almost 4 months से हम पढ़ रहे हैं. So you are requested to be try to be in English. Okay. Otherwise हम ऐसी बोलते रहेंगे ना हिंदी में, बेटा, तो आप हिंदी ही बोलते रहोगे हमेशा. So this is for
सर
you.
वो
only.
क्या बोल सकता हूँ सर इंग्लिश तो, लेकिन वो क्या है जल्दी जल्दी.
No issue. I appreciate your efforts. I always ask you to be in English. Okay, it is not for you; it is for all actually. Okay, so अब like this is a time where we should move on to the English. अभी यदि आप नहीं बदलोगे तो this will be your like problem. It will remains with you. So first of all, the very good example of that one is map. In our daily life, we uses the graph in map. Every time, like wherever you are moving from one place to another, if I want to search some places from my home, distance from my home, any place from my home, I want to book my car for cab. Okay, so whatever it is, they are all are using the map, and that map is nothing but a graph. So the map that you are seeing on your Google or your Google Map or your Android phone or your laptop, whatever it is, they are being represented using the graph. So that was a very big application of a graph actually. Suppose you want to find out the shortest path from one particular place to another particular place, like let us say from Jaipur to Delhi. So there are many ways to traverse from Jaipur to Delhi. Okay, multiple ways we are there, and now we need to find out which one is the shortest one. So for that the graph will be used. And similarly, suppose I want to find out whether there is a flight in between a particular city to another city or not. So again, there are if you go for Google, then it will be represented by the map only. Okay. The another example could be the electronic circuits in our houses. They are also an example of maps. Very good example of map, like the boards you are using in your labs, electronics labs, blackboards and all. So that are also a good example of the maps, because circuit are also being designed by using the maps. Okay, आप देखेंगे कि like from plus to minus there is a particular path. So how they are connected to each other, they follow some properties of being connected. So these are also the particular example of the you can say a graph. Other one could be the communication lines, like telephonic communication are also there. Like when we are talking about the wired communication, so wired like LAN, you can say LAN could be the wired communication in your lab, suppose. So it could be another example of a graph. In every lab in our college is being LANed, properly managed. All the systems are connected through the LAN actually. So LAN is another example of the graph. जहाँ पर हम देख रहे हैं कि where different computers are the nodes, and all the other wires that are there to connect them, they are called as the edges. Similarly, in the case of map, various cities are the nodes, and the roads that are going to connect those cities, like in this particular example, you are seeing ki, one city A, city B, there is an edge between these two. So city A and B are the nodes. Okay. City A and B are the nodes, and the road and the other ways to connect them are called an edge. Similarly, in the circuit, there are multiple points. Okay, and that points could be considered as the nodes, and the wires that are going to connect that nodes are called the edges. Like in your home, you can also see from a switch to the fan. Suppose a wire is going on. So switch, a board, and that fan are the nodes, and the wire between them that is there to flow the electricity is the edge. So wherever you find such kind of the relations between the various things, that could be an application of your graph. So now with the help of that, we can give the definition of a graph. A graph, simple graph. I am using here a word simple graph because different kinds of the graphs are also there. We will learn one by one. So simple graph, that is represented by G equals to VE. So always remember that this particular way is there to represent a particular graph. Okay, so G is equals to VE, consists of V, a non-empty set of vertices, where V is the set of vertices, okay, and E is the set of edges. So मैंने जैसे अभी example लिए of various cities, where cities are represented by the vertices, and the roads connecting to those cities can be considered as an edges. So V is the set of vertices and E is the set of edges. So the combination of vertices and edges are known as a graph actually now. Okay, so it consists of vertices V, which should be non-empty. So it is written over there that consists a set of V which is a non-empty. Okay, non-empty means non-empty
means that this function is include some data and elements or objects.
So this V is a set actually. Okay, it is a set. I am saying it is a non-empty set. Non-empty मतलब खाली नहीं होना चाहिए. It should have something. At least one object or one point should be there for a graph. Okay.
V not equals to
and E and E, a set of unordered pair of distinct elements of V called edges. Okay, that is a very good definition. Like बहुत अच्छी terms हैं इसके अंदर. Now see that V could be non-empty. but E could be empty. यहाँ हमने लिखा है V should be non-empty, but E could be empty. Okay, please remember that thing. I will come on to that point again. Okay, where A is a set of, V is a set of vertices, and E is a set of edges. An unordered pair. What do you mean by unordered pair? Anyone else? Anybody can like explain the term unordered pair?
Sir, may I explain?
Unordered means, what do you mean by unordered? Let someone else explain.
Okay, sir.
Everyone should give a chance. Unordered pair. What do you mean by unordered pair? In set, you might have studied about that. Set theory, I think सबने पढ़ी है.
Sir, please मेरे एक बार सर चांस दे दो सर.
नहीं, मैं दूसरों को बोलूंगा बेटा. Please, anyone else can tell us what about the ordered pair or unordered pair? दो term होती हैं. What one is ordered pair and one is unordered pair. No one has an idea about ordered and unordered pair? It's a pair actually. V is a pair. You might have got the idea with that. G is equals to V, I am writing over there. So it is a pair, V, comma E. Which is a pair of vertices and edges. Similarly, we may have multiple other kinds of the pairs also. So let us move ahead, and afterwards you might have got the idea about unordered and unordered pair. Okay. So simple definition is that the graph G is consisting of the set of vertices which should not be empty, and the set of edges which can be empty actually. Okay. For each E belongs to capital E. Is this particular symbol is clear to all?
Yes, sir. Belongs to.
Is it okay to everyone? Okay, that are mathematical symbols I am using in this. For each small e belongs to capital E, if there should be a E like that, U to V, where U and V are belonging to the vertex set. So what does it mean actually? That like suppose this is U and suppose this is V, the two vertices are there and one edge is there. So that edge will be represented by E. So E is an ordered pair of or unordered pair of U and V. So what do you mean by, can anybody tell me what could be the meaning of ordered and unordered now?
Sir, having no relation.
No. Anyone else? Okay, can I write it likewise? E is equals to V U. Suppose we are having an edge between U and V.
Yes,
So no, why not?
it will change the direction, sir.
But here I am not mentioning any direction.
Sir, we are establishing a relation of U to V.
That is what when we show the direction. Suppose I am showing a direction in that case, then it is U to V specifically. But suppose I am not going to show any direction, then what? Is E is same? Like it could be U from U to V,
Yes,
or
sir.
V to U. Is there like
Yes, sir.
so now tell me what could be ordered and unordered. I have told you to let us wait and move ahead, then you will get understand, I think. So now you tell me, like someone is going to tell us na, what is ordered and unordered.
So unordered is like when there is no direction.
Yes, and ordered means when there is
And
a.
orders means particular direction.
This is actually not a
Means in
correct,
particular-
not exactly exact answer actually. So ordered and unordered. So when I am saying
Sir?
that, yes,
So is it when both U and V are bounded with a certain relation, then we could say that they both form an ordered pair.
not exactly.
Oh, and the direction, when we change the direction of position of u and b, they could be not effect on e any function or relation.
It is not a function, it is not a relation, it is a set, dear. Okay, it is a
Yeah,
set.
yeah.
जब भी हम इसको like इस curly braces I am using, it means it is a set. Okay, so
Okay, sir.
है ना? So unordered means, now let me clear, u comma v is equals to v comma u. That is what unordered means. But when they are not equals to, then it is ordered. Then order matters actually. When the order matters, then they will known as ordered pair. But when the order is not matter, order does not matters, then they are called unordered pair. Now is it okay? Like in this case, if direction is not given, so they are, I can write it either in the like in UV form or VU form. They will represent the same thing. They will represent the same edge. But suppose as soon as I have added a particular direction in it, then what does it means? Ki UV is not equals to VU actually. UV means I am having an edge from U to V. That is okay. But VU means I should have an edge from V to U. But it is not there actually. So we are not saying that UV is equals to VU. Then it is. Then in that case we can say it is ordered now. Order matters actually. Is it okay to you all now? Yes or no?
Yes, sir.
So
Yes, sir.
in simple graph, when there is no direction, we will say that U and V are unordered pair of distinct elements. Now the definition is clear. Every term of the definition is clear now. A simple graph G is equals to V comma E consists of V a non-empty set of vertices and E a set of, where E is this actually, okay, this one, where E is a set of unordered pairs of distinct elements of V, which is called edges. Unordered pair, now it is okay, this is unordered pair. Unordered means U and V, if I am writing U and V or I am writing V and U, both are same. Done? Can we move ahead now?
Sir,
Now-
there are
now-
mentioned that you have mentioned that small u equals belongs to V and small e belongs to E. Can we replace capital V and E through small e and V, small e and UV?
No, we cannot replace. Okay. So now the definition of directed graph. Now directed graph is there. Directed graph GV consists of the set of V of vertices and the set of E of edges that are ordered pair of the elements in V. Is it okay now? The definition is clear now. I have used the term over ordered pair in this, whereas we have used the term unordered pair in this. So I think now it is okay to you all. So what is the direction? Directed graph in which the edges may have some direction. Then that graph is known as directed graph. Is it okay? Yes or no?
But directed
Yes,
graph
sir.
lie
What's
in
the
the
difference between ordered and then
directed?
directed?
Kya? What are you asking?
So then what's the difference between ordered and directed? In ordered also we are saying that we are making a relation from U to V, then it's a direction only.
Nick, we are using the term ordered for pair. This pair. Pair means U and V. This pair is ordered pair now. I cannot replace it VU. I cannot replace this pair with V comma U if it is ordered. But in the case of unordered, I can replace it with this V and U. That is what the unordered means. This is for pair actually. This unordered and ordered term will be used for the pair, but the direction will be used for the edges actually. Okay. Technicality जब हम देखेंगे तो that will be in this manner actually. Ordered for pairs. Pair क्या है यहाँ पर? This is a pair. U and V is a pair, which is representing an edge, which is directed. So direction is for edge and order is for pair. Okay. Now, how can we represent the network of railways connecting the set of cities? Tell me. Can anybody tell me?
How can we
So
represent?
bidirectional.
Bidirectional means कि if I am having a train from Jaipur to Delhi, then there must be a train from Delhi to Jaipur also. So you will
No,
use
sir.
that.
Only single direction, because when we use this particular path to return Delhi to Jaipur, the railway rail number has been changed, because it is one number increase or decreases. जैसे particular for suppose example,
I am not talking about train. I am not talking about train. I am talking about track.
track. No, sir, we are using single way.
How we can represent a network railway connecting a city with the directed or undirected graph?
Directive graph.
Yes. Anyone else can answer? How can we present a network of railways connecting a city of the set of some cities bidirectional? We can use a undirected graph, because I have told you that it is bidirectional. Bidirectional means कि if I am having a like track from A to B, then it should also from B to A. So like suppose in that case I am saying कि one edge is there to represent both things. So it will be easy to represent with the help of simple graph. So where A and B is representing both the directions, from A to B as well as from B to A. But if I will use a directed graph, then I need to make two edges in that case. Okay. Likewise, you can see that. Suppose city A, B, C, D are cities. Okay. What does the edge between A to D means? There is an we can say a railway connection between A and D. It means it is bidirectional actually. From A to B we can go, and from D to A also we can go back. Is it okay now? Similarly, between these different cities are there. But is there any edge between B to E? So is there any connection between the city B to E?
No.
No, sir.
Okay. Now in a round robin tournament, now tell me, round robin tournament where each team plays against each other team exactly once, how we can represent the results of tournaments? Tell me. In a round robin tournament, like it could be a we can say
World Cup.
World Cup, where in which not all the teams are playing against every team. तो जहां हम बात करें, मान लो 4 टीमें हैं, सो एक टीम बाकी तीनों टीमों से फाइट करेगी. Every team will fight the rest 3 teams. Now, suppose if I want to show the result of the tournaments, which particular type of the graph you can use in that? Obviously,
Directive.
in Y. Please answer with the Y also.
Sir, as we are means linking one with others, means there is no backward or forward means.
Okay. Please read the question once again. In a round robin tournament, each team plays against each other team exactly once. Now we can represent the results. So you are going to represent the results only. You are not going to represent the tournament. You are going to represent the result of the tournament. Obviously, the result of the tournament will be in which one team will be winner out of that particular match. Suppose A is going to play with the B, so one team will be the winner, either A or B. Both teams should not be winner, na? Both team cannot be winner actually. So directed graph तो होगा use, लेकिन reason क्या है इसका? Let us look at that. We should use directed graph in that case where A and B indicating the team A beats team B. So in this way we can represent it actually. So this is the way to represent this particular tournament. Like suppose every team, now team A is fighting with every team, other team B, C and D. And when what we can say with the help of this graph, if there is an edge between A to B, so A beats the team B. So if the edge is from A to C, so who is the winner?
C.
C is the
C.
winner. C is the winner or A is the winner?
Team
A to
C.
B. A to B is an edge that indicates team A beats team B. Team A is the winner.
So team A beats the team D, and TA also beats the team B, or team A beats the team C also. Then team A is top.
Okay, so this kind of the situation can be represented using directed graph. Now you can see that here A from edge from A to C means A beating C. A is the winner of the game between A and C. But if I'm going to predict the result of team A and B, so who is the winner? That was B. Similarly in team A or D was winner. And in this way, so हमें केवल एक ही रिजल्ट हमें रिजल्ट शो करना है, तो हमें ये बताना होगा विनर कौन है और लूजर कौन है. तो एक ही डायरेक्शन की एज हमें रिक्वायर्ड है. Suppose in this I will use a simple edge without any direction. So how can I predict that who is the winner in that case? Okay, that's why in these kind of situations we should use directed graph. Okay, now next come on to some other terms that we will use in the graph. So basically two types of graphs we have learned in this particular unit. One is simple graph and one is directed graph. Okay, so next one is, first one is a loop. First definition is of loop. So what do you mean by a loop now? An edge could be a loop if for the edge starting and ending vertex are same. Okay, now suppose this is a particular vertex V, okay, and edge is being there from the vertex U to V only, then that particular edge is called a loop. Is it okay?
Yes, sir.
Okay. Now mixed graph. Next one is a mixed graph. Mixed graph, it means some of the edges will be have some directions, and some of the edges may not have some directions. Okay. So if a graph is a combination of directed and a simple graph, then that particular graph is called a mixed graph. Is it okay? Some edges could be directed and some could be non-directed. Mixed graph is there. So we will not going to learn about that mixed graph now, but you should know what is a mixed graph. That's why I will include that thing in my slides. Now, a graph without any edge is called null graph. I have told you, V and U, we are using two sets that are V and E. V is a set of vertices and E is the set of edges. So, is this a graph? Tell me. How many vertices are there?
Yes, sir. Four.
How many edges are there?
No edges.
No edges.
No edges.
No
So
edges.
in the definition of simple graph, we have learned what we have learned. We have learned that the V should be non-empty. Do you remember that thing? Non-empty set of vertices. But E could be empty in that time. At a time, I have also told you. So that particular graph is also a graph, okay, where only vertices are there. No edge, even no edges there. So can this be a graph? This single vertex be a graph?
No,
Yes,
sir.
sir.
Yes. This
Yes,
could
sir.
also be a graph. And that kind of the graphs are called
Null graph.
no null graph. A graph without any edge is called null graph. If the set E, I could write over there, if the set E is empty, then the graph is known as null graph. We know that V cannot be empty anyhow. यदि V ही नहीं है तो graph ही नहीं होगा. Okay? Is it okay? Now, if more than one edges are associated with the pair of vertices, then such edges are called parallel edges and the graph is called multigraph. Now let me give the answer of that. Oh, example of that actually. Let us suppose this is a graph. Okay, A, B, C, and D. How many vertices are there?
4.
4.
4,
How many edges are there?
4.
4.
4,
4.
Is this directed or undirected?
Undirected.
Undirected.
Suppose I am having multiple edges like between A and D. So 2 edges are there, or it may be 3 also. So these all are edges between a same pair of vertices are called parallel edges. Is it okay now? What are parallel edges? If I am drawing multiple edges between the same pair of vertices, then those edges are called parallel edges, and such kind of the graph is called multigraph. Is it okay? That is what I want to convey with this. If more than one edges are associated with the pair of vertices, then these edges are called parallel edges, and the graph is called multigraph.
Parallel
So
in
the
case,
edges does
but
not seem to be parallel.
they are coming
They are
from
not.
one end, they are in merging on the another end. So how can they be parallel?
Yes, sir.
You cannot like compare this parallel term with the term that you have learned in mathematics.
So these are like the field lines of electric field and all that.
Sorry.
Nothing, sir, nothing.
No, you can say whatever you want. No issue in that.
I was saying these are like field lines of electric field and magnetic fields.
Oh yes, why not? Yes, ये तो हो सकता है ना बिल्कुल, क्योंकि आप यदि मल्टीपल उसमें होते हैं ना एजेस, आप जब इलेक्ट्रिकल फील्ड की या मैग्नेटिक फील्ड की बात कर रहे हैं तो दो पेयर्स के बीच में मल्टीपल वो क्या कहते हैं उसको?
Yes, so we can have multiple, but we don't call them parallel. But over here we are not using the exact term parallel. We are just considering as they are coming from one edge and merging in the.
We should not compare it with the terms that we are using like somewhere else. Okay. So in this terminology, parallel edges are the edges which are like having the same end pair of vertices. That is okay. But in the case of direction, again, we cannot say this one. In the case of direction, again, this is not a true. Suppose direction is this one and one direction is this one, so they are not actually parallel edges because they are having a same end, but their starting and ending vertices are not same in that case. Okay. यहाँ पर because अभी unordered है तो ये सब काम हो रहा है. When we will using ordered pair, then it will not be work. Now, adjacent or neighbors for a graph. If U and V are like two vertices, and suppose I am having an edge between U and V, so U and V are called adjacent to each other. That is very common word, adjacent. जैसे हम पड़ोस में जो रहते हैं उनको भी बोलते हैं कि हमारे पड़ोसी हैं तो adjacent हैं. They are neighbors of us. Okay. If they are connected to one another, then we can say they are adjacent. So now tell me, suppose.
Sir, it is possible, it is compulsory to connect to each other for neighboring.
Yes, for neighboring they have to be connected to each other. Now tell me whether U and W are adjacent to each other or not.
Yes, sir.
Yes, sir.
Yes, sir.
V and W are adjacent to each other or not?
No, sir.
No, sir.
Diagonal elements are not adjacent.
No, they are not adjacent. They are not neighbor to each other because they
Why?
are not directly connected. Because they are not directly connected to each other. If
Diagonal elements are not adjacent.
the elements which are not directly connected to each other, they cannot be adjacent.
Oh, yes, sir. Yes, sir. U and
Yeah,
X will be connected, then they are.
There must be the edge between V and W. Then only I can say they are adjacent to each other. They are neighbor to each other. Okay. If there is no edge between U and V, then I cannot say they are adjacent. Okay. If E equals to U and V, now incident and connected. Okay. Incident क्या होता है देखो. Suppose E is an edge between U and V, then the edge E is called incident with the vertices U and V. ये term हम use करेंगे अपनी graph theorems में, algorithms में. So that's why we are discussing over there, and that edge is also said to be the connector of U and V. Okay, the vertex U and V are called the endpoints of the edge U and V. I have already used these words, endpoints. Okay, now the degree of a vertex. Like in tree, we have also learned about the degree of a particular node. So degree in the tree was, क्या थी degree वहाँ पर?
Number of childs.
Number of childs. Very good. So now in this case, the degree will be, degree of a vertex in an undirected graph is the number of edges. Number of edges incident with that particular vertex. Okay. So number of edges incidenting on that particular vertex. Right now, अभी मैं यहीं पर खत्म कर रहा हूँ. आगे भी लिखा हुआ है ये one sentence. I will first let me clear with that. Okay. So I should come on to the example directly first of all. Suppose these are two vertices O and V. So what could be the degree of O?
1.
1.
1.
1. Okay.
Two.
Now what could be the degree of all these three vertices? OVA.
2.
Why 2?
Because
Because
each element
each vertex has
connects
two connections.
Vertex has two edges.
Yes,
contains two edges.
every vertex is being incidenting with two edges. हर vertex पर दो edges गिर रही हैं. Incidenting means कि lying होना. Okay. So for O we can say from V and A there are edges that are incidenting on O. Same for A from O and V. Same for V from O and A. So now tell me, what about that? If there is a loop.
So there will be twice the edges.
Yes,
Means
that I have already
3
written
times
over there.
2 edges for B and A.
So what could be the degree of O now?
2.
4.
Why 4?
It will be 4. It will be 4. Very
Why?
good. 2 तो पहले ही थी.
Because we will count loop as 2.
Okay. 2
Loop.
तो पहले loop is there, so we will count it as 2 because loop will be considering as incidenting 2 times. That is what the like feature of unordered also. Unordered का feature है actually. Because unordered में हमने एक edge को दोनों तरीके से consider किया हुआ है. Edge from O to V and edge from V to O. Similarly, edge from O to O and O to O again. So loop will be considered always 2 times in undirected graph. I am saying in undirected graph. Is it okay? But in the case of direction, definitely it will be reduced to 1. क्योंकि direction बताएगा हमें कि एक ही direction में edge है हमारे पास. Okay, we will see how in the like in coming slide also. So in other words, you can determine the degree of a vertex is in a displayed graph by counting the number of line that touches it. Okay, जो उसको touch कर रही हैं वो उसकी degree होगी. And loop will definitely be counted as twice. ये चीज हमेशा ध्यान रखनी है आपको. Degree of a vertex will be denoted by a degree of V. In this way, we will represent the degree of vertex, any vertex. Okay, and a graph in which each vertex has the same degree, which is called a regular graph. So again, these are the terms that you should know because they could be there in the multiple choice questions in your examinations. Okay, or they could be the in 2 marks question in your examinations, in your midterm or RTO examinations. Okay. So because definitions are very important right now, तभी मैंने tree में भी और graph में भी and wherever I required, I use a lecture for defining the terms specifically. Okay, so is this graph was a regular graph if I remove that particular loop from that?
Yes, sir.
Because every vertex will have the degree 2 now.
Regular graph.
So now next one is a vertex with degree 0 is called isolated vertex because it has no adjacent to it. So a degree, this simple vertex O, suppose it has no edge incidenting on it, then it is called isolated vertex.
Because
Okay.
it because
It is
its
not
edge-
connected to anyone else. It has no adjacent, and in that case, the degree of this vertex will be 0. Okay. Now, a
सर
degree.
शायद हम कह सकते हैं कि इसकी एज है यदि हम लूप का यूज कर इफ वी यूज लूप देन वी कैन से इट इज contain include edges.
Okay, a vertex with a
Sir?
loop. Yes.
Sir, I didn't get the loop one part, sir.
Sorry.
Sir, loop वाला part sir समझ में नहीं आया sir.
In this particular graph, suppose O is a loop. There is a loop from O to O. So that is what you are talking about.
Yes, sir.
Okay, just remember that whenever the loop is there, we have to consider it twice. Okay, जब भी loop होगा तो उसको हम 2 बार consider करेंगे. So like one is from O to O, again one is from O to O. Like this simple edge is from O to V and V to O. एक तो हमें एक ही edge है लेकिन है ये 2 edges. Similarly, this one is a single edge, but we will consider it as twice edge.
Okay, sir.
Okay, तुम अच्छा. Let me clear. Let me explain some in some another way. Suppose this is specific edge, and these are 2 vertices. So tell me, this edge is contributing for how many vertices as a degree?
2 vertices.
Okay, and suppose this is a particular vertex only, and this is an edge. So this edge also should be contributing for 2 vertices. Yes or no? And that vertex is same actually. That's why we will consider twice for the particular loop.
Okay, sir.
Because every edge must have a start point and a end point. Like for this edge E, suppose this is the start point and this is a end point. तो इसने इसकी दोनों vertices की degree में contribute किया. For this particular edge, this is a start point only, and this one is only the end point also. So it should be contributing 2 times for this vertex. Okay, so in this way you may remember that for loop we will take that twice time contribution for a particular vertex. A vertex with 0 degree is called isolate vertex. Next one is called vertex with a loop. It has at least degree 2, and by definition is not isolated actually, even if it is not an adjacent to any one other vertex. Now what does it mean actually? So this one is an isolate vertex, but is this an isolate vertex?
No.
No, sir.
No, sir, it is connected by
It is
itself only.
It is
edges.
connected by
Self
yes,
edges.
Yes, it has a self edge. Loop is nothing but a self edge actually. Very good. So loop is nothing but a self edge. So it is connecting to itself. So it should not be an isolated. ये अपने आप का adjacent है. Okay. A vertex of degree 1 specifically is known as pendant vertex. So ये terms भी याद रखिएगा. What do we mean by a pendant vertex? Pendant vertex degree 1, isolated vertex degree 0. Okay, pendant means कि it will always be an adjacent to exactly one vertex. Like in this case, this one A, E, B. This all the like both the vertices are of degree 1, so they are pendant vertex. Yes or no?
Yes, sir.
So degree is clear to all now. Degree is the number of vertices or edges that are incidenting. Yes.
So the example which you discussed before, the cities connecting with the railway network. So for example, the same A and B are connected. So sir, why we are taking it as a single directional? You told me that it is a bidirectional example.
So I have told that it is not a single directional, it is a bidirectional.
Then sir, degree of
This edge is being there for contributing, like for A as well as for B. It means I am having a train from A to D and D to A also.
So, sir, then we are assuming that the loop part should be of degree 2. Then why not we are considering the single, matlab, if we need to find out the A to D, between A to D we need to find out the degree of A, then why we are not considering as 2? Because it is bidirectional from A to D and then D to A.
Because right now I am not taking it as a directed graph. The undirected graph में we will consider as it only one edge. Okay,
Then sir, why we are taking loop as 2?
Because it is particularly incidenting on a single vertex only. Here it is contributing for a single vertex, but that edge is contributing for two vertices. That edge A to D, between A to D is contributing between A and D. So it is contributing for both. So because of that edge, we are actually taking the degree of two vertices, you can say. आपने A की डिग्री में भी उसको काउंट किया है और D की डिग्री में भी उसको काउंट किया है, बट वो जो लूप है वो केवल एक की डिग्री में थोड़ी काउंट होगा, वो इट विल बी, दैट्स व्हाई वी आर टेकिंग इट एज अ 2 एक्चुअली. दैट इज द रीजन एक्चुअली. इस पर्टिकुलर एज के कारण एक की डिग्री, केवल एक की डिग्री में ही इंक्रीमेंट नहीं हो रहा है, डी की डिग्री में भी इंक्रीमेंट हो रहा है. सो लूप विल बी देयर फॉर कंट्रीब्यूटिंग इन ए फॉर 2 टाइम्स. दैट इज द रीजन एक्चुअली.
Sir, A will have 3 degree, means from A to A 2 times and from A to D also.
Yes. But now suppose I am having some direction in that. So it will not be going to like participate in the degree of either A or B, A or D actually. ठीक है? Yes or no?
In this,
Now it will contribute for city A and not for city D.
It depends what I am going to take, because in directed graph there are two different kinds of degrees, in degree and out degree actually. We will learn how.
hello.
Hello.
Sir, if we connect A to B and also A to D, and each vertex contain itself edges, then each vertex have 3 edges, or we can say it contains 3 degree.
Yes, yes. Now I think it is okay. Degree is clear to all. Now come some questions on degree. Which vertex in the following graphs are isolated vertex?
Vertex F.
E or F?
F, E, sir. E is
F, E,
F. Because it is not contain any loop.
F.
Okay, which are pendant?
Pendant. मतलब उसका डिग्री
E.
A को.
Sir, E also.
A.
Sir, will you
It's
please
true, sir.
explain the pendant one more
A.
time?
Yes, sir.
Sorry.
Or no
A.
pendant.
Please explain pendant one more time.
Pendant vertex means degree 1.
Degree 1. A है sir.
So which
Degree 1.
A.
Sir, there is no vertex, sir, because E has a loop and it is for
No
twice.
pendant, sir.
There is no pendant loop.
There is no pendant vertex.
A sir. A.
इसमें कोई
Because-
pendant vertex नहीं है.
A,
A,
D,
D,
J.
J, E.
A is a pendant. D is a pendant.
D is pendant.
J,
J
is
or
pendant.
A is pendant. J is pendant. A,
G
D,
pendant. A, D, J. Because they are connected through only one edge.
It is pendant, and this one is also
J.
pendant.
Yes
Because
sir.
they have degree 1. What could be the maximum degree of this work? This particular graph, maximum degree क्या है किसी
So
भी?
the maximum degree is of G.
5.
What was that?
G, sir.
5. 5.
Very good. For G it is
5, sir.
5.
5.
Now tell me what is the degree of B? We will calculate the degree of every vertex now.
2.
2.
For
2.
C,
2.
for
2.
E,
2.
2.
1.
2.
2,
2.
2.
1.
1.
1.
0.
0.
okay. Now which type of the graph it is?
undirected.
This is undirected graph or
Complex? No.
the terms you have studied
Mixed
that
graph.
mixed graph should have directed and undirected edges both.
Simple
In
graph.
this is a simple graph. Very good. Simple undirected graph. Okay. Or one more terms you can use over there in that part. Some loops are also there. That's why it is also known as pseudograph.
So why pseudograph?
Because of loops. A graph that could have a loop, it is known as pseudograph. If it is having a loop in it, यदि किसी ग्राफ में लूप होगा तो उस ग्राफ को हम pseudograph बोलेंगे. वो रह गया पीछे मेरे को बताना था. And I will add that term, that definition also in that. ठीक है? Okay, now let us look at the same graph and determine the number of its edges and the sum of the degrees of all its vertices. Find out the sum of the vertices, sum of the degrees are. Tell me. What is the sum of the degree?
18.
It is 18. And now find out the number
18.
of edges. Number of edges find karo isme.
11.
11?
9.
Who said 11?
7.
Ajay.
7.
Yes, sir, I counted the loop twice.
Okay.
9.
Is loop is not an edge.
Yes, sir, it's an edge.
9.
It is 9.
9.
It is 9.
9. We'll count loop as once only.
Yes. Loop will also an edge. Actually, it is a self edge. So it is considered a single edge only. Okay.
सर मैंने
So
तो इनका सिर्फ आधा कर दिया.
Sir,
total yes, ask.
Sir, it must be 2 na loop for the loop as when we find out the degree, then we count it as 2 times. Then sir, age must be 2 only. No? Age is the number of ages only.
Same reason. Same reason. Between A and B, how many edges are there?
1.
But it is contributing the degree for A and B both. So you should consider it as 2 edges. So do not confuse with this term कि हम loop को 2 बार consider कर रहे हैं degree में consider करने के लिए. Loop is a single edge.
Sir, over here we are just checking the edge of particular vertex, and if we check the edge in particular direction, like what's the edge from A to B, then only we can say what is the edge of from B to A or B to C.
Yes,
only
yes,
single. Then
yes.
it will be 1 only.
Yes, again, I think Divyanshi has asked why we are considering from A to B only 1. That is the reason again. वहाँ पर एक ही
Yes,
edge है
sir.
यहाँ, लेकिन अब as 2 थोड़ी consider कर रहे हैं बेटा हम लोग, है ना? So edge is single. What it will contribute in the degree, it doesn't matter. It will not increase the count of that edge actually. So here we are having overall 18 degree of the vertices, and that is what the reason I have specifically added that particular thing. अब आप देखो कितनी edges हैं, 9 edges हैं, and degree कितनी है? 18 degree.
18.
तो
Just twice.
just twice. ऐसा होना चाहिए undirected graph के अंदर.
सर आधा कर
That
दिया
is
था
what-
मैंने प्रूव में
That
दिया
is
था
the property of that actually.
एजेस का आधा कर दिया था सर मैंने.
Sir, is it valid for each and every undirected graph?
Definitely. Because every new edge will increment which we can say every edge is when we will add the edge, it will contribute the degree of 2 vertices. So जहां 2 डिग्री बढ़े, एक एज ऐड हुई, 2 डिग्री बढ़ गई ऑटोमेटिकली. Yes or no? Say yes or no.
Yes, sir.
Suppose I am going to add a particular edge from A to D. So definitely, as soon as I have added one edge only, the degree of A and D will increment. तो डिग्री कहाँ, डिग्री डबल, डिग्री 2 टाइम इंक्रीमेंट होगी एक एज ऐड करते ही. अब वो चाहे लूप हो, तो दैट इज द रीजन कि वी आर कंसीडरिंग लूप एज ट्वाइस डिग्री. अब सपोज आई हैव एडेड लूप ओवर देयर ऑन F, so it will contribute the degree for F as twice. Is it okay now?
Yes, sir.
Done. So we will move on to the, what is the time? It is 12:07. So we should end over there. From next slide we will move tomorrow. Is it okay? Should I close the meeting now?
Okay, sir.
Okay, sir.
So let me take the attendance first. Anybody wants to ask anything, then you can ask. Otherwise, we can end the meeting and you all can leave.
Sir, एक क्वेश्चन था.
Yes.
सर, आप बाइनरी सर्च ट्री का एल्गोरिथम इम्प्लीमेंटेशन करने के लिए प्रोग्राम दोगे?
Definitely in lab we will do it. Okay, in coming lab, next lab we will do it. Like yesterday we have done heap sort. Then in coming lab we will do the binary search tree.
Okay, sir.
Anything
Sir,
else
heap
anybody
sort-
wants to ask?
हीप सॉर्ट सर आपने थ्योरी में पढ़ा दिया है?
नहीं, we will do it only in the lab. I have discussed that thing in the in yesterday's lab. Sorry. Yes, I have discussed yesterday only.
Okay, sir.
Okay, so thank you very much for today. I am stopping.